A shocking theory claims that mysterious comet Oumuamua might be a von Neumann probe, an alien spacecraft with broken engines tumbling through our solar system. It sounds extremely unsettling, but first things first, what is a von Neumann probe? Mathematician John von Neumann suggested the concept of self-replicating spacecraft that could in some ways mimic the features of living organisms or viruses. People started to refer to such hypothetical spacecraft as von Neumann probes. Von Neumann was sure that using self-replicating spacecraft would be the most effective way to perform large-scale mining operations, like mining asteroid belts or moons. The creators of such probes could take advantage of their exponential growth. Hypothetically, a self-replicating spaceship could be sent to a neighboring planetary system and look for raw materials there. Such materials could be extracted from moons, gas giant planets, asteroids, and the likes. Using these materials, the probe could make replicas of itself. The replicas could then be sent to other planetary systems, and the original probe could pursue its main purpose within its parent star system. This pattern sure does repeat the reproduction patterns of bacteria. That's why some experts think that von Neumann machines could be considered a form of life. There's also a theory that a self-replicating spacecraft could spread throughout a galaxy the size of the Milky Way in just 500,000 years, even if it used conventional theoretical methods of interstellar travel. In other words, it wouldn't even need to employ exotic faster-than-light propulsion. In 1981, mathematical physicist and cosmologist Frank Tipler argued that extraterrestrial intelligence couldn't exist because people had never observed von Neumann probes. Even if we take a moderate rate of replication, such probes should already be common throughout space. So, it's really weird that we haven't come across any of those yet. It might only mean that extraterrestrial intelligence doesn't exist. A response to Tipler's arguments came from astronomers Carl Sagan and William Neumann. They pointed out that Tipler might have underestimated the rate of replication, and von Neumann probes should have already started consuming most of the mass in our galaxy. Therefore, any intelligent race would avoid designing von Neumann probes in the first place and try to destroy any probes as soon as they found them. Another objection to the prevalence of von Neumann probes is that civilizations that could potentially design such devices have an extremely high probability of self-destruction before producing such a machine. In any case, the assumed capacity of von Neumann probes is unlikely in reality. But then, how about Oumuamua? These days, scientists are using high-tech scanners to examine a huge, cigar-shaped comet, which might or might not be an alien probe. One idea is that it's an extraterrestrial civilization spacecraft, with broken engines wandering through our solar system. If that's the case, the object could easily be a von Neumann probe. Dr. Jason Wright from Penn State University thinks that a broken alien spaceship could move in exactly the same way as Oumuamua. Rather than moving through space like other space rocks, the 1,318-foot-long, 118-foot-wide space traveler is tumbling through the solar system. At the moment, it's traveling at a speed of around 200,000 miles per hour. In his blog, Dr. Wright says that if such derelict craft were not traveling fast enough to escape the galaxy, they could thermalize with the stars and end up drifting around like an interstellar asteroid or comet. They wouldn't have attitude control anymore and would eventually start tumbling. And it could distinguish them from regular interstellar asteroids. Plus, even though their propulsion was broken, their radio transmitters could work just fine. In any case, so far, it's just a theory, and further research is needed. What do you think? Is Oumuamua just a space rock or an alien space probe?
We still can't find the source of the mysterious signal we've been receiving since 2018. We receive it every 22 minutes and nothing can explain this. Some scientists even believe it could be coming from another civilization we haven't met yet. This strange radio signal wasn't found by a scientist on a serious mission. It was actually discovered by a college student just doing a regular project for school. Tyrone O'Doherty, an undergrad student at Curtin University in Australia, was sifting through old data of the southern sky. He was looking for any weird blinking radio signals. He finally stumbled upon one from 2018 that seemed to shoot radio waves towards Earth like a lighthouse beam. Excited about his find, Tyrone shared it with his mentor, radio astronomer Natasha Hurley-Walker. She dove into researching this signal, hoping for a breakthrough. But despite checking different frequency data, they hit a dead end. But then, Natasha spotted a pattern. The signal repeated every 18 minutes. This was huge. But just as they were gearing up to study it further, poof! The signal vanished after only 3 months, leaving them with nothing. Not giving up, Natasha and her team scanned the skies again, desperate for a clue. Months passed, but nothing turned up. They were ready to give up, and then suddenly, a new signal popped up. This one kept blinking for 5 minutes, then it disappeared. And then it came back exactly 22 minutes later. The main question was if that signal was related to an 18-minute one. To figure it out, Natasha went back to the old radio data from that area. As they dug deeper, they realized that, yes, and these signals aren't anything new. They've been beaming towards Earth for 35 years. Back in 1988, Indian and American telescopes had caught them, but they got buried under tons of other data. This was great news for space explorers because it meant they could now calculate how far away this mysterious object was. After doing the math, they figured out it was incredibly far, even on a space scale, 15,000 light-years from Earth. Now, the only thing left to uncover was what exactly this object was. Walker and his team started comparing it to all the known radio-emitting objects out there. Yet its source remains a mystery. The signals still pop up every 22 minutes on NASA screens, always ending with a frustrating match not found message. The scientists called it J183910. Some think that the signal might come from some extraterrestrial beings. Maybe it's the signal that SETI, the search for extraterrestrial intelligence, has been waiting for. This project has been working for over 50 years, trying to find any evidence of life beyond Earth. They also scan the skies for radio waves, laser pulses, and other mysterious signals. So maybe it's a way for extraterrestrial folk to communicate their location. While that idea may sound exciting, we need to be careful about jumping to conclusions. First, we don't have solid proof for that. Before any concrete evidence, it's just speculation. And also, there are other more plausible explanations. Most likely it comes from a natural phenomenon, and there are a couple of theories for that. The first one is the pulsar theory. Imagine a huge star in space much bigger than our Sun. Sometimes these big stars finish their life journeys in a spectacular event called a supernova. When this happens, the star's core collapses, becoming super compact, as if you're squeezing all the stuff from that star into a tiny space. That tiny, super-dense core is called a neutron star. Some of these neutron stars are extra special. We call them pulsars. They get their name because they seem to pulse with energy, like a space lighthouse. These pulsars have incredibly strong magnetic fields, much stronger than what you'd find on Earth. They're like enormous magnets in space. Because of this, they shoot out beams of energy. They're also spinning super fast, so these beams of energy seem to pulse on and off as they spin around. Now, the strange signal we detected seems to have similarities with pulsars, but not quite. Pulsars usually have a predictable lifespan and slow down over time, eventually stopping their radio signals. In contrast, our mysterious signal is quite persistent and is blinking beyond what's expected for pulsars. So, maybe it's not a typical pulsar, or not a pulsar at all. There's also a magnetar theory. Now, a magnetar is another type of neutron star. They're like supercharged versions of pulsars, with even stronger magnetic fields and slightly longer pulsating periods. Maybe this is what causes our signal's intense persistence. However, when we plotted the data, We also realized the signal didn't match the magnetar's vibes either. Magnetars not only send out radio waves, but also powerful X-rays because they're so energetic. But the signal we received was only sending out radio waves. So we figured it's not a pulsar and not a magnetar. The signal's behavior is very strange and suggests an unnatural source. This means there might be something in the universe that scientists haven't fully explored yet. And there is a space object that we don't know much about. The final theory is the so-called dwarf pulsar. Sounds a little dopey to me. Couldn't help myself. Now, a dwarf pulsar is like a star that blinks with light flashes, similar to pulsars, but it takes longer for each blink. Usually, white dwarfs are the leftovers from smaller stars. They don't blink because their magnetic field isn't as strong as pulsars. But when a white dwarf becomes pretty hefty, almost the mass of our Sun, it gets super dense and starts pulsating with a strong magnetic field, just like pulsars. They have a cool quirk. White dwarfs are made of electrons, not neutrons like pulsars. When these charged electrons start dancing with the magnetic field, they shoot out periodic light flashes, which happen every 100 to 1,000 seconds. As you remember, our signal has a period of 22 minutes, 1,320 seconds. A bit longer than the usual white dwarf pulsars, but it's much closer to the truth. So far, this sounds like the most plausible explanation. But even this theory isn't fully confirmed yet. This just shows how much there is in the universe that we're still figuring out. For example, fast radio bursts, another mysterious type of signal we've been detecting. They're like quick, intense bursts of energy in the form of radio waves. They have a ton of energy. FRBs are so powerful that sometimes they can be brighter than entire galaxies. Now, imagine this. They release as much energy in a few milliseconds as our Sun does in 3 whole days. Wow! These bursts happen all over the sky with huge frequencies, although some have been detected with lower frequencies. Every day, we catch around 10,000 random FRBs in the sky. Some of them repeat, but most happen once and disappear forever. Unfortunately, most of them only last for a fraction of a second, and by the time their energy reaches us, it's 1,000 times weaker than a mobile phone signal from the moon. This is why, despite their brightness, there's still a lot we don't understand about them. We're still trying to figure out what causes these FRBs. They could be coming from different sources, like already mentioned magnetars, colliding stars, or even merging galaxies or white dwarfs. As these bursts travel through space, they pick up information about the cosmic environments they pass through, like interstellar gas clouds. It's very unlikely that FRBs are some messages from extraterrestrial beings, though. Not only because there are thousands of them every day all across the sky, but also because we know that the sources of these bursts must be incredibly energetic themselves. Our neighbors would have to have equipment stronger than entire galaxies for that. But the bottom line is, while all these signals are fascinating, there's still a ton to learn about them. Voyager 1, which has been traveling through interstellar space for more than 45 years and is trailing a long gray beard by this time, not really. It suddenly began to send strange signals to Earth. Even more bizarre, there are no signs that the probe has broken or anything. Scientists from NASA are desperately trying to find the reason. So, what's happened exactly? First of all, let me tell you a bit more about Voyager 1 and its long journey. Voyager 1 is an American space probe. Scientists from NASA sent it into space on September 5, 1977. Voyager's goal was to explore the outer planets of our solar system, namely Jupiter and Saturn. Initially, scientists assumed that the mission would take about 5 years. Haha, the joke's on them. The probe exceeded all expectations. Not only did it fulfill its mission, but it's still working for much longer than expected. Voyager 1 has been wandering around space for more than 45 years. It's hard to estimate what Voyager 1 has done for science. Firstly, it successfully sent a lot of photos of Jupiter and Saturn to Earth. By the way, you can even check out these photos yourself. All of them are published on the NASA website. Thanks to Voyager, we also discovered several new moons of Jupiter and a previously unknown system of its rings. We learned that Jupiter's famous red spot is actually a giant superfast storm. And after leaving Neptune's orbit behind, Voyager also sent a lot of important data about interstellar plasma. So Voyager 1 successfully proved to scientists how useful it was. After that, it happily headed for its next goal, the Kuiper Belt and the heliosphere. The Kuiper Belt is a ring of icy bodies that extends from Neptune to a distance of approximately 50 AU from the Sun. It's kind of similar to the asteroid belt, but about 20 times wider and 100 times heavier. And the heliosphere is an area around the Sun where the pressure of the solar wind is balanced with the pressure of interstellar gas. Yeah, I know, it sounds like some hard scientific stuff. Just keep in mind that this data really helps us understand the universe as a whole. So, this is Voyager's last task, to tell us more about interstellar space. The probe has already sent us more than 60 frames for a mosaic of the solar system from a distance of over 4 billion miles from Earth. Scientists used these frames to make a big colored picture. The photo was called the pale blue dot, and you've probably already guessed what that dot is. Yep, that's what our Earth looks like through Voyager's eyes. This photo clearly shows how tiny we really are, and how precious and fragile our planet is. But Voyager 1 also has another, even more important mission, to tell other civilizations about us humans. You might have heard about the famous Voyager Golden Records. People created many audio and video files and added them to these records. There are a few sections. The first one contains hello in 55 languages, including ancient and extinct ones. Almost 80% of the recordings are different musical pieces, like Bach, Beethoven, Mozart, and Stravinsky, folk music from different countries and ages, and a bit of the blues, like famous songs by Louis Armstrong and Chuck Berry. The remaining 20% of the recordings contain different human voices, sounds of nature and animals, as well as 116 images encoded as audio signals. There's also recordings of speeches by Kurt Waldheim, a former UN Secretary General, and Jimmy Carter, a former US President. These are just some friendly messages. In addition to the records, scientists also packed a needle for playing them. Don't worry, they also left a simple drawing that showed how to use all this stuff and how to translate the sounds into pictures. They added Earth's coordinates, which they created using a pulsar map. It shows the position of the Sun in the Milky Way. The record was packed in an aluminum case and covered with gold to protect it against radiation and cosmic dust. Carrying this record, Voyager 1 set off on its long journey, and it has already traveled quite a distance, I'd say. Right now, Voyager 1 is 154 astronomical units away from us. That's about 14.5 billion miles. This makes it the most remote human-made object. Initially, this title belonged to the Pioneer 10 mission, but Voyager overtook it in 1998. What a bargain for NASA! It's way beyond its best-by date. Voyager 1 is actually so cool that it even overtook its twin brother, Voyager 2, which, by the way, had been sent into space 2 weeks earlier. Voyager 1 moves at a speed of 9.7 miles per second. That's 35,000 miles per hour. Even the fastest sports car in the world travels at a speed of only 305 miles per hour. So it's hard to imagine the speed of Voyager. Anyway, at the moment, Voyager is heading to the borders of the Oort cloud. That's the name of a hypothetical layer of icy objects surrounding the solar system. Astronomers haven't confirmed its existence yet, but they're almost sure it's there. After all, even black holes were only a theory not so long ago. Unfortunately, Voyager 1 won't return back to the solar system. It'll keep in touch with Earth at least until 2025. But eventually, we'll lose the connection with it for good. In 300 years, it'll reach the borders of the Oort cloud. And in 30,000 years, I won't be around then, it'll finally leave the solar system. And if nothing happens to it along the way, in another 10,000 years, Voyager 1 will approach red dwarf star Gliese 445 in the Giraffe constellation. In the future, the probe will probably keep wandering around the Milky Way galaxy. And now, let's finally discuss the mysterious signals part. So, what happened? Well, a rather unusual thing. NASA's Jet Propulsion Laboratory, which monitors and controls both Voyagers, reported this problem in May 2022. Our veteran spacecraft suddenly began sending strange data to Earth. The whole situation puzzles even engineers from NASA. Now, I bet you're thinking, come on, the thing just probably broke down or something. But the truth is that Voyager 1 is totally fine. It works as usual, receives and carries out commands from Earth, and collects and sends scientific data. But the readings of the AACS, which stands for Attitude and Articulation Control Subsystem, don't show what is actually happening to Voyager anymore. This system supports the orientation of the probe in space and helps it keep in touch with Earth. So, basically, the signals mean that the probe's orientation in space is messed up. But scientists claim this is not the case. They know that the source of the antenna signal remains in the same position relative to Earth as planned. The problem hasn't triggered any of the onboard fault protection systems. The probe hasn't even entered safe mode. So, what in the world, or universe, is going on? Suzanne Dodd, the head of the project, says that the problem is not actually that unexpected. After all, Voyager 1 is already 45 years old. The expert admits that what's happening to the probe remains a mystery to them. They don't know exactly where the incorrect data is coming from, and it's unclear how this will affect the operation of Voyager. She adds, though, that it's not that surprising, considering that the probe is in interstellar space. There's a very high level of radiation there. No spacecraft has ever reached that point before. Scientists from NASA say they'll keep closely monitoring the data coming from Voyager 1 until they figure out the problem. If they find it, the management team will try to fix it. Otherwise, the team will have to adapt to the new conditions. It might not be enough just to understand the problem, though. It takes as much as 20 hours and 33 minutes to receive the signal from Voyager, and it takes the same amount of time to respond to it. Well, at least the second spacecraft, Voyager 2, is totally fine, even though it's also currently in interstellar space at a distance of 12 billion miles from Earth. Anyway, we can only wait for news and hope that the problem will be resolved. I actually wonder how much longer can Voyager 1 last? Will it be able to fly to the borders of the Oort cloud in 300 years? What do you think? I'd like to hear your thoughts in the comments.
It's the year 1977, and astronomers are stunned. They've just picked up a bizarre and really powerful radio signal coming from the direction of the constellation Sagittarius. The signal shockingly matches the frequency of neutral hydrogen. What's the big deal? This is the very frequency many astronomers believe might be used by extraterrestrial civilizations trying to communicate. Since then, the signal has become legendary in the search for extraterrestrial intelligence, aka SETI, community. But what exactly was that mysterious signal? To understand this, let's go back to the 1970s when the Ohio State University Big Ear Radio Telescope was active. For more than 2 decades, from 1973 to 1995, it played a major role in the university's SETI program. By the way, it was the longest-running SETI project in history. And in 1977, Big Ear detected something extraordinary, the WOW signal. This wasn't just any signal. It was a strong narrowband radio signal, right near the important neutral hydrogen frequency. The Big Ear telescope might be gone now, but the mystery of the WOW signal still fascinates scientists today. Imagine this. You want to tell an extraterrestrial civilization about humans. How would you describe our average height? We can't use feet or inches because these units mean nothing to them. Even here on Earth, we don't all use the same measurements. To communicate with other civilizations, we need a universal way of conveying information. Luckily, the emission of light by matter comes from an electron jumping between quantum states in an atom. This process, governed by quantum mechanics, results in specific and fixed radiation frequencies and wavelengths, no matter where you are in the universe. Since we believe the laws of physics are the same everywhere, these wavelengths are universal. This makes them a perfect standard of measurement that any civilization could understand. For example, on the Pioneer spacecraft's gold plaque, we used a particular wavelength as a unit of length to describe information about humans and the spacecraft's origin. So, if an extraterrestrial civilization wanted to talk to us, they could have used the frequency of the wow signal. And that's pretty amazing. The signal lasted the entire 72 seconds that Big Ear was tuned in. A few days later, astronomer Jerry R. Ayman was looking over the data when he spotted the unusual signal on a computer printout. He was so surprised that he wrote "wow" next to it, and that's how the signal got its famous name. The signal also has another, not-so-exciting name, 6EQJ5. Some people thought it might be a hidden message, but it actually just shows how the signal's intensity changed over time. The wow signal sparked all kinds of theories. Some people believed it was a sign of extraterrestrial life, while others were sure that it was some interference from human activities. There were those who believed it could be a natural phenomenon we didn't understand yet. New research seems to have finally solved the mystery, but there's one thing we'll talk about a bit later. First, let's get into detail. A team of scientists, led by Abel Mendez from the Planetary Habitability Laboratory at the University of Puerto Rico at Arecibo, revisited the mystery using data from the now-closed Arecibo Radio Telescope, collected between 2017 and 2020. These observations were similar to those made by Big Ear, but they had better sensitivity, resolution, and polarization measurements. Arecibo detected signals similar to the wow signal, but there were some important differences. These signals were less intense and came from multiple locations. The scientists believe that these signals, including the original wow signal, can be explained by natural events in space. Their theory sounds like this. The wow signal was likely caused by a sudden brightening of hydrogen due to a strong, short-lived radiation source. It could be a magnetar flare or a soft gamma repeater, SGR. A magnetar is a neutron star with a way stronger magnetic field than ordinary neutron stars. And an SGR is an astronomical object which emits large bursts of gamma rays and X-rays at irregular intervals. In any case, such events are pretty rare and depend on very specific conditions. But they can cause hydrogen clouds to light up for short periods. According to the researchers, what Big Ear picked up in 1977 was one of those bright hydrogen clouds in its line of sight. The study suggests that the signal's rarity can be explained by the precise alignment needed between the radiation source, the hydrogen cloud, and the observer. It means that the wow signal may actually be the first recorded instance of an astronomical maser flare in the hydrogen line.
Since 2007, astronomers have been receiving super-strong and ultra-bright radio signals that last just a few milliseconds. Such mysterious flashes are called fast radio bursts. They seem to be coming from billions of light-years away. Not so long ago, researchers were lucky enough to capture a repeating radio burst that flashed 6 times in a row. Who knows, it might help us crack the puzzle of these signals. But hold on, it's just the first mystery on our list. If nuclear pasta does exist, it's the strongest material in the entire universe. Formed from the leftovers of extinguished stars, this substance is squeezed into spaghetti-like tangles of material. It can break, but only after you apply 10 billion times the pressure needed to shatter steel. That single, high-energy neutrino that hit Earth in 2017 wasn't extraordinary on its own. Scientists observe such neutrinos at least once a month. But it was the first one to arrive, carrying so much information about its origin that astronomers could actually point their telescopes in the direction it had come from. They found out that the neutrino had been flung at our planet around 4 billion years ago by a flaring blazar, a supermassive black hole at the center of a galaxy. Saturn's moon Hyperion is one of the most bizarre-looking moons in the solar system, but its appearance isn't the strangest thing about it. This pumice stone-like rock, pockmarked with countless craters, is also charged with static electricity which is flowing out into space. Lost in space and drifting through galaxies, rogue planets were once flung away from their parent stars. But one of them, 200 light-years away from Earth, is different from the rest. It's a planet-sized object with a magnetic field 200 times stronger than that of Jupiter. This field is so powerful that it generates flashing auroras illuminating the planet's atmosphere. When a team of astronomers at Louisiana State University first spotted this star, they were totally baffled. The object, nicknamed Tabby's star, dipped in brightness at irregular intervals and for odd periods of time. Sometimes the difference in brightness reached 22%. Could it be due to the activity of some alien megastructure? Unlikely. The main theory claims that the star is surrounded by an abnormal ring of dust, which causes the darkening. DJI-SAT-1 galaxy is as big as the Milky Way, but it's nearly invisible because its stars are spread out incredibly thinly. But what makes the galaxy so unique is that it's sitting all alone. Unlike other galaxies of this kind, which are usually found in clusters. It can mean that DJI-SAT-1 was formed in a different era, probably a mere 1 billion years after the Big Bang. If it's true, the galaxy is a real living fossil. Massive objects curve light so much that it can distort the images of objects behind them. When astronomers used the Hubble Space Telescope to detect a quasar from the early universe, they used their discovery to calculate the expansion rate of the universe. Strangely, they discovered that, currently, it was much faster than it used to be. That finding contradicted other measurements. We still don't know if our theories are wrong or if something bizarre is going on in our universe. Neutron stars are ultra-dense collapsed cores of giant stars. They usually emit X-rays or radio waves. But in 2018, astronomers discovered a weird stream of infrared light. It seemed to be coming from a neutron star 800 light-years away from our planet. This signal was probably generated by a disk of dust surrounding the star. But this theory hasn't been proven yet. Haumea, a dwarf planet orbiting in the Kuiper Belt, has a bizarre, elongated shape and 2 moons. The day on this planet lasts 4 hours, making it the fastest spinning big object in our solar system. But the most enigmatic thing about Haumea is that the planet has a thin 40-mile wide ring circling it. Dark matter is believed to make up 85% of the universe, and researchers used to be sure it was everywhere. But in March 2018, a team of scientists discovered a peculiar galaxy that seemed to contain little to no dark matter. Later, though, it was proven that this space oddity did, in fact, contain dark matter. Moons orbiting other moons might exist, or they might not. Astronomers haven't agreed on this yet. Planets orbit stars, moons orbit planets, then why can't there be moons, also known as submoons, moonets, and muons? Researchers claim that moons could exist. But the host moon has to be massive enough, the moon small enough, and there must be a wide gulf between these moons and the host planet. The James Webb Space Telescope has recently discovered 2 candidate exoplanets, orbiting their host white dwarf stars. Those are collapsed husks of once great stars. Why is this discovery so exciting? First of all, because these alien planets strongly resemble the largest gas giants in the solar system, Jupiter and Saturn. And secondly, because this discovery might shed light on what our home solar system will look like after the sun's inevitable demise. Our sun is bound to turn into a white dwarf, and this change will most likely destroy the inner solar system all the way out to Jupiter. So far, astronomers have spotted very few planets orbiting white dwarfs. What makes this latest find even more unique is that the planets are more similar to the planets in the outer solar system, in temperature, mass, age, and orbital separation than any other previously found space bodies. It allows us to see for the first time ever what a planetary system looks like after the demise of its star. The candidate planets in question were directly observed by James Webb's mid-infrared instrument while orbiting their parent white dwarf stars. One of these exoplanets is located quite far from its star, at a distance equal to around 11.5 times the distance between Earth and the Sun. The other planet is even further away from its extinguished stellar parent, at a distance of 34.5 times the distance between our planet and the Sun. So far, scientists haven't figured out the masses of the potential planets yet, but they're estimated to be between 1 and 7 times the mass of Jupiter, which is the most massive planet in the solar system. Now, let's sneak a peek into the future. When the Sun runs out of its stellar fuel, and there is nothing left to support nuclear fusion processes in its core, it will swell up into a red giant. It will happen in around 5 billion years. but nuclear fusion will continue in its outer layers, which will reach out as far as Mars, swallowing Mercury, Venus, Earth, and probably even the red planet itself. In the end, the outer layers of our star will cool, leaving behind a smoldering core. Our warm yellow dwarf star will turn into a white dwarf, surrounded by a planetary nebula made up of exhausted stellar matter. The outer planets are likely to drift outward into wider orbits after the sun goes out. It means that the newly discovered candidate planets might have orbital separations, similar to the ones Jupiter and Saturn will have in the distant future, and if astronomers confirm these space bodies, they will provide us with direct evidence that such planets as Jupiter and Saturn can actually survive the demise of their host star. Researchers have also discovered an interesting fact about the white dwarfs themselves. Apparently, they're polluted with elements heavier than helium and hydrogen. Astronomers call such substances metals. This finding could hint at what might happen to the celestial bodies in the asteroid belt, stretching between Mars and Jupiter after the sun goes out. Scientists have a suspicion that giant planets, like our Jupiter and Saturn, might cause metal pollution by hurtling asteroids and comets into the surfaces of their stars. The existence of such planets makes the connection between this kind of pollution and planets stronger. And since 25 to 50% of white dwarf stars experience this kind of pollution, giant planets must be common around white dwarfs. It means that 5 billion years from now, Jupiter and Saturn might be hanging out there in the darkness of space, tossing asteroids at the sun's lifeless body. By the way, about 97% of all the stars in our home Milky Way galaxy will become white dwarfs with time. That's because most stars are not massive enough to turn into anything other than white dwarfs when their lives come to an end. It means that once all the stars in the Milky Way pass the white dwarf stage and cool down into theoretical black dwarfs, the Milky Way will become pretty much invisible. If the universe is everything, then there is nothing external for it to expand into. But we know for sure that it does expand. So the question is, what exactly is it expanding into? According to the theory of cosmic inflation, the universe was once filled with large amounts of energy. It was similar to hypothetical dark energy, but much greater in magnitude. It made the universe expand faster and faster. As a result, the universe was getting colder and emptier. And then, after growing this way for a very long, possibly infinite amount of time, most of this energy got converted into matter and radiation, which triggered the Big Bang. The Big Bang was the moment when the whole universe was squeezed into a tiny, super hot, and extremely dense ball we call a singularity. And all of a sudden, when it was less than 1 second old, this tiny ball started to unpack at speeds we can't even imagine. It was so hot that particles were moving extremely fast, crashing into one another and creating pairs with their opposites, like matter and antimatter. When the universe was 1/100th of a billionth of a trillionth of a trillionth of a second in age, it experienced an incredible burst of expansion that we know as inflation. At that moment, the universe doubled in size at the speed of light. And after that, it doubled in size at least 90 more times, growing from a subatomic-sized formation to a Gulf-sized structure almost instantly. After this burst of inflation, according to NASA, the growth of the universe continued, but it slowed down. As the universe kept expanding, it started to cool down, and matter formed. 1 second after the Big Bang, and the universe was already filled with neutrons, protons, electrons, anti-electrons, photons, and neutrinos. If we somehow managed to observe the universe when it was just a trillionth of a second old, we'd see that it was the size of Earth's orbit around the sun. When the universe was a mere 1 second old, it was too hot for nuclear fusion to occur. At that time, its radius was just 10 light years, which is enough to enclose the 9 nearest star systems we know about. When the universe was 1 year old, it was smaller than our home galaxy and unbelievably hot. Finally hot enough to start nuclear fusion. When the universe was 3 years old, it was roughly the size of the Milky Way galaxy. when matter started to dominate radiation, which happened when the universe was around 10,000 years old. The size of the universe was about 10 million light-years. It would be easy to think of the Big Bang and the resulting expanding universe as an ordinary explosion, where everything is expanding from a central point. But it's not a good analogy. There's a better one. Look at the surface of an inflating balloon. It'll be a two-dimensional equivalent of our three-dimensional universe. The balloon fabric will be space. These dots marked on its surface will represent galaxies. You see, they're moving apart as the balloon expands, but it happens only because the fabric, representing space itself, is expanding. The galaxies aren't moving on their own, and there's no central point for the expansion. The balloon is expanding into the third dimension, and that's where the analogy is getting trickier. Does it mean that our universe is expanding into some higher dimension? If there's no larger multiverse and our universe is all there is, then there's nothing outside of it. Not even a vacuum, which is still part of space. It means there's no point in asking what the universe expands into. If there was a two-dimensional being on the surface of our expanding balloon, they would be able to observe all distances in its surface 2D world getting larger. But they wouldn't see the third dimension into which the balloon is expanding. The same goes for us. Three-dimensional creatures. We see the distances between galaxies growing, meaning the inflation of space, but we can't perceive additional space dimensions into which the expansion is moving beyond our three. Even if space is indeed expanding into some higher dimension, our current knowledge of physics doesn't allow us to find out anything about it. It's likely to be beyond our comprehension.
It was the spring of 1900 when a group of Greek sponge divers got blown off course by a storm and came across a wreck of an ancient Roman ship. The vessel, which had sunk more than 2,000 years before, was literally loaded with treasures. A year later, a spectacular haul of antiquities was brought up to the surface, and among those precious items, there was something amazing. Divers found a startlingly complex cosmological calculator. It was one of the world's first analog computers, and it was made by the ancient Greeks between the 3rd and the 1st century BCE. It could track the phases of the moon and the position of the planets, but we can't give all the credit to the Greeks. Most scientists believe that their knowledge was based on the learning of a much earlier civilization. The ancient Babylonians were considered the first astronomers, and no wonder. They were enthusiastic stargazers. For example, around 6,000 years ago, they built watchtowers to scan the sky. And after mapping the stars and visible planets, they recorded their observations on clay tablets. Now, let me tell you about the most paradoxical thing. The observations made by the ancient Babylonians were extremely precise. They were the first known people to predict eclipses. They successfully calculated the length of a year. But their understanding of the cosmos? Oh boy, it was so different from ours. See for yourself. They imagined their world as an oyster surrounded by water. Their sky was a solid dome. Moisture sometimes seeped through this dome as rain. The waters from below sometimes broke through this dome in the form of natural springs. And every day, the sun, the moon, and the stars took part in a slow dance across the ceiling. They entered from the east and exited in the west. Now let's move on to another great nation, the ancient Egyptians. Their universe was rectangular, kinda box-like. At first, they believed the sky was a cow, with each of its feet planted at each corner of the rectangular earth. Later, they changed their mind. They started to compare the sky to a vaulted metal lid. The deities of the sun and moon sailed along the river, flowing upon an elevated gallery running around the inner walls of the box. Early Greek cosmology was no less exciting. Their world resembled a floating disk that was surrounded by Oceanus. That was a majestical mythical river encircling the world. But this theory was soon debunked. With time, the ancient Greeks started making tremendous advances in figuring out how the universe actually worked. Even better, they became the driving force behind the development of Western astronomy and science. If we speak about the solar system, in the past, there were two theories about what it looked like. The first one was called heliocentric. That's because the sun was considered to be the center of the known universe. Earth was believed to revolve around the sun once a year and rotate around its axis once a day. At least, this theory managed to correctly map all the planets known at that time in order of their distance from the sun. The other theory was known as the Earth-centered model of the universe. According to it, our planet was the center of the universe, and all other space bodies, including the sun, rotated around Earth. This model was around for about 1400 years. It was toppled only in the 16th century. You might have heard that in the past, people believed that our planet was flat. Interestingly, this myth had already been debunked by the 5th century BCE. It was widely accepted that our planet was a sphere. Ancient astronomers watched lunar eclipses and observed the shadow our planet cast on the moon. It was clearly round, which made them conclude that Earth was a sphere. And still, despite some correct theories, the ideas of ancient civilizations about the world often seem somewhat funny and naive to us. On the other hand, guys, I guess the day will come when our descendants will start discussing our theories about space, and I bet they'll find them both ridiculous and amusing too. The universe is three-dimensional. Okay. No, the universe is four-dimensional. 3 dimensions for space and 1 for time. Okay, duh, what are you talking about? The universe has 9 dimensions. Okay. Come on, guys. The universe is flat. Wait, what? However strange it may sound, all these statements are kinda true. How come? The theory of general relativity allows for the universe to take one of 3 forms. It can be flat, like a sheet of paper. It can be completely closed, like a sphere. Or it can be shaped like a horse's saddle. It's very important to figure out the shape of the universe. This way, we can learn about its past and future. It can answer crucial questions. Is the universe going to expand forever? Or will it eventually collapse? Is it finite or infinite? Here, we need to consider 2 factors: the density of the universe and the rate of its expansion. Now, hear me out. About 68% of the universe is dark energy, 27% is dark matter, and the remainder is normal matter. That's what stars, planets, and our bodies are made of. And when we speak about the universe's density, we mean the amount of matter packed into a given volume of space. And the density of the universe is so great that its gravity is more powerful than the force of its expansion. Then the universe will curl into a sphere. This is what we call the closed model. The coolest thing about such a universe? Even though it is finite, it has no bounds. However paradoxical it may sound, if you found yourself in this universe, you would travel its space forever without falling over an edge or hitting a wall. But if the density of the universe was low, it would be unable to stop its expansion. In this case, space will warp in the opposite direction, creating an open universe shaped like a saddle. But the most popular theory, and the most bizarre-sounding one, is that the universe is flat. It might be possible if its density is just right, and it expands in every direction without curving negatively or positively. Scientists claim that it's the most plausible scenario, by the way. So, if you're disappointed by our planet's roundness, the flat universe might come as some consolation. But what does a flat universe mean? I mean, our 3D world seems very real. Can it be just an illusion? Nah. The flatness of the universe isn't that 2-dimensional flatness you might be imagining right now. To help you understand this concept better, I'll tell you this. In a flat universe, 2 rockets flying next to each other will always remain parallel. In a closed universe, their paths will diverge, and they will follow the curvature of space and eventually make a loop and meet where they started. And in an open universe, these rockets will separate and never come across each other again. Of course, it'll take a lot of time to prove that the universe is indeed flat, But so far, astronomers don't have even the slightest reason to doubt this theory. All the data they have is consistent with this flatness. For example, the imprints left on galaxies from sound waves that occurred right after the Big Bang also support this theory. In other words, right now, scientists agree that the universe we live in is like a three-dimensional sheet of paper. Good luck trying to imagine this. But if this idea is wrong and the universe is actually curved, it must be ginormous, because those 93 billion light-years we can observe aren't a large enough portion to let us see even a tiny curvature. So, it might be wrong to say the universe is flat. It's probably better to announce that the little bit of the universe we see is flat.
A single brain filled with fake memories of having existed in our universe. Once, this brain just spontaneously formed in a void. Sounds like something from science fiction. But this brain could actually be me. Or you. There is an idea that such a brain is more probable than an entire universe that came about in the manner cosmologists think it did. And this phenomenon I'm talking about is known as a Boltzmann brain. Let's see. A brain is coming into existence in our vast universe right at this second. And everything in this brain is forming at this moment. The memories of its previous life, obviously fake, its origin, its ideas, and the perspective of the universe. But this brain perceives itself as real. In this case, how will it know that its memories are artificial and its existence is no more than an illusion? This is what the Boltzmann brain paradox is about. It's the result of Ludwig Boltzmann's debate with other scientists on the interpretation of entropy. According to the second law of thermodynamics, the entropy, or disorder of a system, can stay the same or increase, but it can never decrease. Have you ever seen shattered glass return to its previous state? Neither have I. But Boltzmann stated that even though the probability of the entropy of a system staying the same or increasing is high, it doesn't mean that the probability of the entropy decreasing equals zero. This chance is just so small that it can be ignored. But everything changes when we speak about some infinite system. If such a system, for example a universe, has an infinite number of particles, there must be at least one possibility that these particles create something structured. Let's take an infinitely old universe. Such a universe means an infinite number of possibilities where the entropy increases, and a tiny chance of its reduction when particles come together and form a structure instead of existing randomly. So Boltzmann took this idea of an infinitely old universe and ran with it. He claimed that at some point, all those randomly organized particles the universe contained could come together and form a structured system. Maybe this formation of a structure even led to the Big Bang. One more idea he suggested was of a local system existing in an infinitely large system. It could be a universe containing structure and life and existing in the infinite system of a dead multiverse. Such a multiverse would have no structure, which is what high entropy suggests. And since we know that in an infinite system, there can be only one possibility of entropy reduction. All other universes except one would be dead. Interestingly, Boltzmann said that we don't need an entire universe or even a galaxy to confirm the existence of structure in a dead multiverse. The only thing we need is just one intelligent observer. And what part of the body is responsible for consciousness and cognition? Right, the brain. It could be a single brain randomly existing somewhere in a high-entropy dead universe, containing memories of its entire life. Scientists had to admit the legitimacy of this paradox, and still, everyone was sure they could never be a Boltzmann brain. Everyone knew their existence was not artificial. But that's exactly what a Boltzmann brain would think. After all, it wouldn't know that its memories and existence are fake. This realization caused quite a commotion in the scientific world. People started to research the probability of one being a Boltzmann brain, and it turned out that the existence of a Boltzmann brain in an infinite universe is way higher than the probability of a human brain. Statistically, we are more likely to be Boltzmann brains than real breathing creatures. But it's too early to fall into an existential crisis. Sure, there's no way to find out whether you are a Boltzmann brain or not, but there's a catch. do you remember that we've been talking about a Boltzmann brain in the context of a universe which has existed for an infinite amount of time? But our universe hasn't existed forever. On the other hand, what was there before the Big Bang? Nothing? Or a dead multiverse where all the particles came together and caused the Big Bang, which led to our structured universe? Sounds uncomfortably close to the description of the Boltzmann brain universe.
The morning is cloudy, but it isn't raining. So you grab your bag and head off to work. You're halfway there when it starts drizzling, then raining, then pouring. There's only one thought in your head as you're dashing through wet streets towards your office building. If only I could hop in a time machine and go back in time. I'd have put that umbrella in my bag. Unfortunately, going back in time is not possible. But guess what? We still managed to travel in time. But let's start from the very beginning. More than 100 years ago, a famous scientist called Albert Einstein, I bet you've seen his most popular photo, came up with a theory about how time works. He gave it a nice little scientific name, the theory of relativity. According to it, space and time are linked together. Another point is that our universe has a set speed limit. Nothing can move faster than the speed of light, which is 186,000 miles per second. Okay, you may say, but what does it have to do with time travel? Well, the theory of relativity also claims that the faster you move, the slower you experience time. And several experiments prove this to be true. For example, let's say you have two clocks set to the exact same time. You leave one clock at home and take another one with you while traveling by plane. What's important here is the fact that the plane is going in the same direction as Earth. After your plane finishes its flight around the world, you can compare the time on the two clocks. You find out that the clock that traveled with you is a bit behind the clock that remained on the ground. Because of this, GPS clocks are corrected. GPS satellites travel around our planet at tremendous speeds, around 8,700 miles per hour, and more than 12,000 miles above the surface of Earth. This speed slows GPS satellite clocks down, but the altitude speeds them up. As a result, the clocks on GPS satellites experience time at a rate that is slightly faster than 1 second per second. And if this difference in time wasn't corrected, you wouldn't be able to use GPS to figure out your exact location. In any case, this is probably the closest thing we have to time travel. You see, our planet is constantly moving around the sun at an average speed of 67,000 miles per hour. The sun, along with the entire solar system, is, in turn, circling the center of our home Milky Way galaxy at a staggering 140 miles per second. And the Milky Way itself is also moving. It's spinning at a speed of 130 miles per second. Those are some really dizzying numbers. And now imagine that in order to get to the past, all this space matter must also turn back and return to its original position. Just admit it, it's absolutely impossible. By the way, even though we can't exactly travel back in time, we can look at the past, thanks to NASA's space telescopes. They help us see stars and galaxies that are insanely far away. It takes the light coming from them ages to reach Earth. That's why when you observe those distant worlds, you see what they looked like a long time ago. Now, what if time travel was somehow possible? Wouldn't all the fun be spoiled by the time travel paradox? You know, like finding yourself in the past and accidentally preventing your parents from meeting each other? The problem is that Einstein's theory of general relativity theoretically allows a person to travel back in time and come in contact with their past self, which can potentially endanger their existence. But you can breathe out. Some scientists at the University of Queensland have recently claimed that this paradox might not actually exist. They say that even if you made some changes in the past, the timeline would self-correct anyway. In other words, it would still ensure that whatever event sent you back in time would still happen. One more study claims that even if some changes happened in the past, they wouldn't drastically alter the future.
Stars are beautiful, colorful things. There are red giants. Those are nearing the end of their lives and are on the verge of explosions. Blue stars shine in the belt of the constellation Orion, as well as other places. Yellow ones, like our sun, are pretty ordinary. They're usually warm and stable enough to support life. But look at the night sky attentively. Do you see any green or purple stars? Nope. They're kinda invisible because of the way we humans perceive visible light. The color of a star mostly depends on its surface temperature. The hotter it is, the shorter wavelengths the light it emits will have. The hottest stars are blue or white blue. Those are some of the shortest wavelengths of light. Cooler stars are normally red and red-brown, which are longer wavelengths. At the same time, stars never send out their light in just one wavelength. It's more of a range of light. The wavelengths of light from a star peak in just one color in a bell-shaped curve. But the star emits other colors too. Human eyes have evolved to see yellow and green radiation, probably because our sun emits it mainly in these wavelengths. But a green star emits radiation right in the center of the visible light spectrum, in all possible colors. That's why such stars appear white, which is a combination of all hues. Actually, our sun emits quite a lot of green light, but we perceive it as white. Purple stars, though, are something our eyes won't ever see because they're sensitive to blue light. And since stars emitting purple light send out a lot of blue light too, because these shades are next to each other on the visible light spectrum. The human eye picks up only the blue light. When it comes to other objects in the solar system, many planets seem to have no obvious hue. Look at Venus, Saturn, or Jupiter. They look kinda bland, probably whitish at best, but there are several planets that boast very decisive colors. For example, Mars looks orange-red, Neptune is blue, and Uranus has a beautiful blue-green hue. The planet gets it from all that methane gas in its atmosphere. Meteors sometimes display a vivid green too. And look at breathtaking bright auroras. Green is the most common color of the northern lights. But not stars, never stars. The brightest star in the sky, besides our sun of course, is Sirius. It's twice as bright as its competitor, Canopus, located in the southern constellation Carina. Being the most brilliant, Sirius is very easy to identify. Probably the coolest thing about this star is that it seems to be changing its color. But we'll get to it a bit later. This star is whiter and hotter than the sun. Its surface temperature is 17,300 degrees F, while the sun's surface temperature only reaches 10,000 degrees F. When you combine the immense heat Sirius emits with its girth, 1.75 times the size of the sun, you'll understand why the star looks so bright in the night sky. Sirius has a companion star. It's called the Pup. It's a tiny but incredibly dense white dwarf with a diameter of a mere 7,000 miles. This makes it smaller than Earth. At the same time, its mass reaches 98% of that of the Sun. It means that the matter inside this tiny star is squeezed very, very tightly. That's why its gravitational pull is 350,000 times greater than Earth's. A person weighing 150 pounds would weigh 50 million pounds on this star. Now, Sirius is famous for its twinkling, and since it is also the brightest star, we can observe the ever-present turbulence in its atmosphere quite well. As for the star changing its color, it has to do with the atmosphere of our planet. Pockets of air at different temperatures focus starlight this way and that like small lenses. We see it as twinkling. But since white light is made of different colors, one pocket might send some red our way. Another will send blue or yellow in totally random order. That's why it seems that Sirius twinkles in color.